We are analyzing graphs of polynomial functions, and we want to use the x-intercepts to graph the polynomial function. Using x-intercepts, sketch the function by plotting the x-intercepts and the y-intercepts and plotting points between and beyond the x-intercept to determine the end behavior. So if we look at this example one here, we see that we have three factors. And so if we were to distribute all of these factors to one another, we would know that this is going to be degree 3. So degree 3 means that it is an odd function, or the highest degree is odd. And so we know that there's going to be our 3 zeros, and we want to pay attention to what the end behavior is going to be. So we can draw our slope monster, and we see that this one is negative, this one is positive. If it's up and down, that's undefined, and straight across, that is 0. And we know that our lead coefficient in this case is positive, or our A value is positive. So that means that we are going to be dealing with a positive slope in this case. So we know or what we should expect to see is we should see a graph that starts low and then finishes high with end behavior. So it should look something like this for a degree 3 when we're going through. Okay, now let's go and see a little bit more exactly what it looks like. And we know that because we have 3 factors and they're all multiplied together, if any one of these 3 factors is 0, the whole thing will become 0. So we can use our zero product property. And our zero product property says if this is 0, the whole thing's 0. So what would make this become 0? Negative 2. What would make this become 0? A 1. And what would this make it become 0? A 3. So we know that we have these zeros at negative 2. We have a 0 at 1. And we have a 0 at 3. Okay, so that's where our zeros are going to be. We also know that our graph, our end behavior, is going to start and come up, and then it's going to come down, and then it's going to finish somewhere up here. But we don't really know what's happening in the middle. So there's some points that we can pick out. We can check where 2, we can check 0, and we can check negative 1. We check those values and we get a better idea of what the graph is doing, and then we can get a good graph from there. So we have the function, and let's evaluate the function at 0. So we have the function evaluated at 0, and that will be equal to 0.25, and then 0 plus 2, 0 minus 1, and 0 minus 3. So if we evaluate this function at 0, zero plus 2 is 2, minus 1, minus 3, and then we multiply by 0.25, and we know that that will end up being 2 times negative 1 is negative 2, times negative 3 is 6, times 0.25 is 1.5. So then we can get the ordered pair 0, 1.5. So on our graph, we go to 0, and then we're up to 1.5, and we know that we're going to have a point there that we should go through. Another point that we can check is we can check negative 1. So we have the function, and then we're going to evaluate it at negative 1. So 0.25 times negative 1 plus 2 times negative 1 minus 1 times negative 1 minus 3. And we're going to substitute in negative 1 there. And then we will get 0.25. -1 plus 2 is 1. -1 minus 1 is -2. And -1 minus 3 is -4. -2 times -4 is 8. Times 1 is still 8 times 1/4, and that's going to be equal to 2. So we know that we have the ordered pair -1, 2. So if we go over on our graph, we go to -1, and then we go up to 2, we're starting to see what our graph is going to look like. Start up here, come down, it's going to cross the x-axis, and then we're not sure exactly what happens here. And so we can check one more point, and that point that we want to check is 2. So we can have the function, we want to check the function, and we want that function to be evaluated at 2. That's equal to 0.25, and we're going to check it at 2. And then -1 and -3. And we're going to substitute in +2. So we get 0.25. 2 plus 2 is 4. 2 minus 1 is 1. And 2 minus 3 is -1. So -1 times 1 is -1, times 4 is -4, times 0.25 is -1. So we get the ordered pair 2, -1. So at 2, we're down to -1, and we can see what we're doing. And we've already talked about what our end behavior is going to do. As it goes positive, as x becomes positive, we're going to go to positive infinity. As x becomes negative, we're going to go to negative infinity. So when we go to plot our graph, we're going to start down, we're going to go up, we're going to cross, we're going to go through the y-intercept, keep coming down, try to make our curve look smooth, and then we're going to continue and have our end behavior go in that direction. And if we want to check to see what it looks like, these are some points. Now we can see that we have a minimum here, which is 2.12, -1. That's not what we calculated, right? We calculated it at 2, -1. So the one we calculated wasn't the lowest point, but it just gave us an idea of what the graph looked like. Same thing with our max here. We come up, and right now the max says it's at -0.786. We didn't calculate the max. We calculated at -1, which just kind of gave us an illustration of what the graph might look like. And then we also found our zeros at -2, 1, and 3, and then our y-intercept as well.